मित्रांनो, आपल्याला हे मेकॅनिक्स विषयी जे आपलं टीचिंग लर्निंग चालू आहे आणि साहजिकच आपल्याला ह्या सगळ्या गोष्टी अशा आजच्या ह्या काळात अशा रीतीने समजून घ्याव्या लागत आहेत. याचा त्रास साहजिकच तुम्हाला सुद्धा होत असणार आहे. But we have to accept the challenge and thereby we are approaching the situation and day by day or lecture by lecture we are going ahead. In mechanics, we have been started from the part that is acceleration due to gravity. And for getting the acceleration due to gravity, how the pendulums are used to find out the acceleration due to gravity. What are the types of pendulums and how the improvement to remove the drawbacks of the pendulum are to be done. Then the concept of interchangeability of center of suspension and center of oscillations we have been also studied. In last lecture we have seen the Newton's law of gravitation also. That Newton's law of gravitation is nothing but F equals to G into M1 into M2 by R square. This was the Newton's law of gravitation. Then afterwards we have been seeing the terms that gravitational field, then gravitational field intensity. The notation of field intensity was E, and that E is given by Gm by R square. Gm by R square, and afterwards again gravitational potential we have discussed it, and we got the relation that V, gravitational potential V, is given by V equal to minus of dV, difference in the potential to the distance, difference in the distance. In this way, today we will now see gravitational potential due to a solid sphere. See, this gravitational potential due to a solid sphere is, yes, now here we will see gravitational potential due to a solid sphere. See now, for getting the idea or for finding the gravitational potential due to a solid sphere, again here we have to go through the three conditions, or we have to find out the gravitational potential for the three conditions. That conditions we will see one by one. First, the gravitational potential at a point outside the sphere. Then one condition is here the gravitational potential at a point on the solid sphere, and gravitational potential at a point inside the solid sphere. These are the three conditions. Then today here we will see gravitational potential. First condition we can say that condition we will see, write it A, that is gravitational potential at a point outside the solid sphere. Solid sphere. See, friends, solid sphere is a body which is formed due to concentric spherical shells, and due to which here we have to draw the diagram by which we will get the idea how the point P is outside the solid sphere. See, this is the center of the sphere, and these are nothing but the concentric spherical cells this is center having a notation O. This point which is outside of a solid sphere is denoted by the point P, and this is R, the radius of that solid sphere we can say. M is the mass, and another distance is noted by R. See, now in this diagram we are able to see P. P is a point, this P is a point which is situated at a distance R. This is a distance R from the center of the solid sphere, and the mass of this solid sphere is nothing but a M. M is the mass of this solid sphere, and capital letter R is the radius of this solid sphere. Radius R is the, then see, to find the we can have for showing the radius we can draw in this way. Then here again we have to find out the gravitational potential at point P. At this point we are interested to find out gravitational potential. Then again in beginning we have discussed that the sphere is nothing but it is made up of number of concentric spherical shells on one inside the other, and the shells having the masses M1, M2, M3 in this way. These concentric cells M1, M2, M1, M2, M3. In this way we can say M. Then therefore the gravitational potential at P due to each spherical cell, the gravitational potential at a point P outside the solid sphere due to each spherical cell is equal to, we having a formula, is equal to minus of mass of spherical shell divided by distance or r and into g is a gravitational constant here, and therefore hence now the potential at P due to the different cells we have to calculate it. See friends, hence potential at P due to potential at P due to different cells is nothing but if one cell or first cell having a mass m1, then minus of m1 into g divided by r. Again minus of m2 into g upon r. Again we can write minus of m3 into z upon r. Up to n we can say. Once again we will see m1 is nothing but the mass of spherical cell first, m2 second spherical cell, m3 so on. Since, see now the potential is nothing but a scalar quantity, and the potential due to the whole solid sphere is given by, now notation of potential is V and is given by, how it is given, then we have to make addition of this potential which is getting by the different shells, and therefore it is nothing but in bracket we can take summation or addition m1 plus m2 plus m3 and bracket close into g by r, into g by r. But see once again, this m1, m2, m3 is nothing but the masses of the spherical shells, means that total mass of the sphere is denoted by m, means m1, but we can write here m1 plus m2 plus m3 equal to capital letter M, and by putting this m is the mass of total solid sphere, and hence gravitational potential P, here the gravitational potential at P means at this point the gravitational potential, now we have V equal to by putting this m into z divided by r. See, and again in beginning we have been taken it is minus n. From here, 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 because in basic gravitational potential is a negative quantity and its maximum value is 0 at infinity. मित्रांनो, आपण आता ग्रॅव्हिटेशनल पोटेन्शियल ड्यू टू अ सॉलिड स्पेअर याच्या we are learning the different cases, out of which just one case we have been learned, that is gravitational potential at a point outside the sphere. Gravitational potential हे स्पेअरच्या बाहेर किती असतं, तर त्याची एक केस म्हणजे जर समजा ग्रॅव्हिटेशनल पोटेन्शियल आपण कॅल्क्युलेट करतोय आणि पॉइंट आहे, तो पॉइंट त्या स्पेअरच्या बाहेरच्या बाजूला स्मॉल लेटर आर ह्या डिस्टन्सवर आहे असं आपण गृहीत धरलं होतं. आणि स्पेअर we have been considered that sphere is nothing but it is made up of number of concentric spherical cells, and therefore the gravitational potential we got, that is V equals to minus of mg by r. That now in that conserve means the gravitational potential at a point on the surface of solid sphere. Second case, or we can say that it is a B, and we will say that gravitational potential at a point on the surface of solid sphere, at a point on the surface of solid sphere. See here, last was the case, gravitational potential at a point outside the surface of the solid sphere. Now the point is situated on the solid sphere. See now, this is a solid sphere and the point is situated on this. See now, in this case the distance, see this is a point P and this is a center O. See now, what is happening here? See, the sphere is made up of number of concentric cells, and by which here this is the sphere, O is the center of the sphere. We can understood a point on the surface P, and r is the distance of that point from the center of the sphere, Again the radius is the same, that is a capital letter R, and in this case R is equal to the R, and therefore if the point P lies here, we can write the thing, if point P lies on the surface of the sphere, then what happens? R equal to R means the distance of that point lying on the surface of the sphere, that the small r is equal to the radius of the sphere, we can say that, and therefore we have a relation, very simple, V equals to minus of mg divided by small r, because r equals to r. And here, see now, in this chapter, this type of different cases, and therefore in exam what happens when they ask the question, describe, or the question is derive the expression for gravitational potential at a point outside the solid sphere, then someone jumbles, it confuses himself and write in this way. That is the wrong thing. Therefore, consider by the perception and clarity in our mind that gravitational potential at a point on the surface, this is a P point which is situated on the surface of a solid sphere. This is thing. When he says that gravitational potential at a point outside the surface of a solid sphere, then outside means this is outside. This is outside, this is on the surface, and another case, next time we will see inside the surface, inside the solid sphere. See this? Okay.